quickly recap what we've already learned about the CPU. You know it's responsible for processing instructions. That's literally all the CPU does. And to do that, it does something called the FDE cycle, the fetch, decode, execute cycle. But what makes one CPU faster and more powerful than another? Today, we're going to understand and answer the big question: how do clock speed and number of cores affect the performance of a CPU? We need to learn this because understanding how these factors influence the CPU's performance helps us make sense of why some computers are faster than others, and how CPUs are optimized for different types of tasks. So to go back just a little bit, how does the CPU process instructions? Well, it does the fetch, decode, execute cycle. This is how the CPU processes instructions. It fetches one instruction from primary storage, decodes that instruction to understand what it needs to do, and it executes it. And it does this billions of times per second. Clock speed determines how many FDE cycles can happen per second. Each CPU has its own predetermined clock speed, and it's measured in hertz. For example, if I had a CPU that could do 1 FDE cycle per second, then that would mean that it's going at 1 hertz, or 1 instruction executed each second. But we all know that that's not reality. We don't do 1 instruction per second. We know we're at billions now. But in the past, we would calculate the performance of a CPU in kilohertz, doing thousands of cycles per second. That was potentially near the 80s or 70s, where CPUs were running in kilohertz. Maybe in the late 80s to early 90s, computers were running at megahertz, so they could do millions of instructions per second. But nowadays, we know that all of our CPUs are able to perform billions of instructions per second, which is why they are now measured in gigahertz. The computers in front of you are all the same. They've all got the same CPUs within them, or at least the same specifications. And it's the same as the CPU that I'm outlining here today. The clock speed of your computers and my computer is 2.3 gigahertz. That means it can process up to 2.3 billion instructions per second. And you can see that here where it says 2.3 gigahertz, where it says base speed. That is our clock speed. But we can also see that in actual fact, in reality, my CPU is performing 3.72 billion instructions per second. So how is it able to go higher than my clock speed? Well, that is because of the number of cores that it has. My CPU has 6 cores, which means that it can perform the FDE cycle independently 6 times. Let me show you what that means. If you've got a single core processor, then that means that one core does 1 FDE cycle and you're performing 1 instruction at any one time. But with a dual core processor, where it has 2 cores, you can then do 2 instructions simultaneously at the same time. And inevitably, what actually happens is we can calculate CPU performance by multiplying the number of cores by its clock speed. For example, a single core processor running at 2 gigahertz will go at 1 times 2. So still just at 2 gigahertz, that's 2 billion instructions per second. But if I double the number of cores, but keep the clock speed the same at 2 gigahertz, it will now be able to perform double the number of instructions every second at 4 gigahertz. A quad-core processor going at the same clock speed will be able to perform 8 billion instructions per second, or going at 8 gigahertz.